Hello, calculus fans. When we talked about the integral test, we had a remainder estimate, and just like the integral test, we're going to have one for alternating series. And so the alternating series estimation theorem says that if you have an alternating series where S is the sum, and this converges according to the alternating series test, that is, b sub n plus 1 is smaller than b sub n for all n, and the limit of the b sub n's is equal to 0, then we can put a bound on the absolute value of the remainder by saying that it's smaller than the next term, b sub n plus 1, at least the positive portion. It's a really powerful thing in the sense that we only have to look at the next term to determine a bound on the error. We'll talk about this in class about why this is true. I'd like to estimate this alternating series accurate within 10 to the minus 3. If we let b sub n be equal to the non-alternating portion, the 1 over square root of 2n plus 1, we can see that b sub n decreases to 0. Right? It has to be decreasing and it has to go to 0. That tells us that the series converges by the alternating series test. Right, so that has to happen for us to use the alternating series estimation theorem. So we know that the bound on the remainder is smaller than the next term. So basically I'm plugging in n plus 1 in place of n to get the next term. And so we want all of that to be smaller than 10 to the minus 3. All right, let's solve for n. All right, so if we do a little bit of algebra, we get 10 cubed is smaller than the square root of 2n plus 3, which means if we square both sides, we'll get 10 to the 6 is smaller than 2n plus 3. And now this gives us a bound on n. So what this means is we need to choose n bigger than 499,999. That's what we get if we compute this number and then round up. Remember that n has to be a whole number. That will ensure that S sub n will approximate the series accurate to within 10 to the minus 3. Now, this is terrible. This is a huge number of terms to have to calculate just to get an accuracy of 10 to the minus 3. That's awful. 10 to the minus 3, I'm not asking that much. And so we have to get 500,000 terms just to make sure that we're accurate to within 10 to the minus 3? Very bad. But sometimes that's the nature of some series that are very slow to converge. Okay, that's all for now.